To start off this question, let's approach it by determining what we have that is going to be intermediates in the reaction. These are the things that show up on both sides of the equation. I've already gone ahead and marked them out, but here we see NO3 shows up as a product, but also as a reactant. We also see NO2 starts as a reactant and shows up as a product. And we also see NO as a reactant and NO is a product. So these are all things that are being produced and consumed. So let's take note of that when we're going through and writing out the entire equation. Now, they've conveniently told us that we have double the first equation, so we don't need to go ahead and figure that out on ourselves. So let's start writing. We have 2N2O5, which is going to then go, and we'll see there's nothing left to react with it because these are all going to show up as intermediates. So this is going to react to produce 1, 2, 3, 4 N2O, NO2, sorry, and then plus 1 O2. Okay, now because NO2 shows up as a final product, this means that even though it's a reactant, it's not actually an intermediate, because even though it's produced and reacted, we do end up with a net gain of it. Versus our other things that we're working with, which are intermediates, such as our NO3 and our NO that we work with. Okay, now let's go through and figure out the proposed mechanism and see if this is valid. So let's start by writing out what our rate is going to be equal to. We know that the rate of the total reaction is going to be equal to this guy right here, the second equation, which is K2 times NO2 times NO3. And that's lovely and all, but are we able to get this in terms of N2O5? Well, let's work through it. So, crunching through this, let's see that we can have from the first equation, let's consider NO2. So we see here that NO2 is, by steady state approximation, the rate at which we're producing NO2 is going to be equal to the rate at which we are consuming NO2, right? So the rate at which this is going on here, we'll say that we have N2O5 times K1, producing it, which we will sum, or say, sorry, we're not summing. That's the only thing producing it. We're not going to count this middle equation because we are both producing and consuming it. And this third equation is extremely fast. So this is going to be in an equilibrium state. So this, we can say, is going to be equal to our NO2 times our NO3 times K minus 1. Okay, so now we know that the rate of our reaction as a whole, we can go ahead and substitute this in, these guys here into here, and we'll say that our rate as a whole is going to equal K2 times K1, and then divided by K minus 1 times N2O5. And this is consistent with the predicted rate law, which is that it is proportional to just N2O5, which is awesome. That's what we like to see. And this has actually gone ahead and solved the last part of this question for us, which gets us K1, K2 over K minus 1.